I would start at this point with the first speaker on the materials. We are really honored to have with us David Peck from University of Delft, and who will talk about circular built environment, material challenges, and remanufacturing opportunities. Hi, David. I can see you there.
Hello. Hello. Good to see you.
It's a pity you couldn't join us physically at the end, but we are very happy to have you here also just virtually.
Yes, I'm pleased to be here. Hopefully you can see my slides now coming up.
Yeah, we can.
Fantastic. Thank you very much. Great. Thanks for the introduction, and thank you everybody online and also of course there. I actually will be in Milano at the end of this month, so I can travel then, but I couldn't right now. So I'm sorry, but I am coming. I'm coming to Milano because I love it. I'd like to talk, as was introduced, about circular built environment, materials challenges and remanufacturing opportunities. And the presentation is going to be split into two in that way, that I will talk about the challenges, and the challenges are enormous and are right now today scaring me quite a lot, but the opportunities are there as well. A festival of logos, forgive me, but I'm funded mainly by the European Union, and we have a lot of projects. I should also give a call out to the reason I'm coming to Milano this month. I work with the MIP Graduate School of Management in Politecnico di Milano, where we run circular programs there. So that's really exciting. Let's jump straight in and start talking about the challenge. Oops, here we go. So yeah, circular and critical materials, and that's what I want to start off talking about. First of all, let's just, and I'm sure you've had plenty of presentations already on what is a circular economy, and I've been involved with the Ellen MacArthur Foundation for a long while and connected to them. I just want to make some things clear though, because there's sometimes some confusion. And some folks are talking about a circular economy. What we mean is recycling. And by the way, if you'll notice as well on the butterfly diagram here, I haven't shown the green biocycle side, simply because that's not my area of expertise. It's incredibly important, but not my focus today. Nor is my focus on recycling, which is material reuse, and it's the only way you close the loop on materials, and sometimes also known as secondary materials. So you'll hear me talking today about primary materials, and they're materials that are mined, which is at the top of the diagram. What I'm really interested as well is in product life extension strategies, circular product life extension strategies. And my focus today will be on remanufacturing, and I'll explain that more in a moment. But I just wanted to get those two terms separated and understood by everybody, because often I hear people, policymakers and companies, mixing them up like they're the same thing. They should be interconnected, by the way, and this diagram doesn't show that very well, but I'll talk more about that in a moment. Okay, let's do a little bit of policy, and I can speak, I don't speak for policymakers in the Netherlands, but obviously as a Dutch citizen, I'm familiar with policy and circular in the Netherlands. One of the policy areas that we have on circular in the Netherlands is called the transition agendas. And you see there are 5 transition agendas around consumer goods, food and biomass, plastics, construction and manufacturing. Interestingly enough, although I'm from an architecture and built environment faculty, my focus is a lot more on the manufacturing side, and you'll understand why in a moment. What are some of the targets that we're talking about? And by the way, these targets apply all across the European Union as well. Well, first of all, a dramatic reduction in energy consumption. That has to be a given, and energy is occupying our minds right now, be it at work or in the home. Then reduction in climate emissions, and I like the Fit for 55 expression. If you've not heard it, get to learn it and get to know what Fit for 55 means. 55% reduction. This isn't just politics and blah, blah. This is, we either hit 55 or we can't keep anywhere near within 1.5 degrees warming. And if we can't keep within 1.5 degrees warming, we might as well forget everything. Thirdly, the final point, and I'll put it in bold, 50% reduction in primary material use. Let's just pause on that for a moment. 50% reduction in primary material use. This is mined materials, half. And let's just remind ourselves again, 2030. Oh yeah, that's quite a few years. Oh yeah, actually it's 7 years, 10 months away. 7 years, 10 months, we are going to halve our primary material use. So now let's say some other things. So by 2027, 2026, we're going to have a 25% reduction in primary material use. By the end of next year, we need to be 10% down in primary material. Whoa. How many people in the room who work in companies or other organizations have serious, robust plans for a 10% reduction in primary material use at the end of next year? And then the room goes quiet, I suspect. So it's not going to be easy. Even companies with good carbon targets, what they'll often find is in terms of primary material use to meet the carbon targets, the primary material use is increasing. Now I want to delve into the world of critical materials. And it's not well understood, and I hope there are some in the audience that do know about it, but it's not unusual for me to speak to audiences where it's not well understood at all. And here I'm taking the methodology from the European Union, because after all, that's what we work to. And this is the framework, which is the framework in the EU. And it comes around two axes on a two-axis graph. And the first is economic importance. So in other words, if you take a material, how important is it to the economy? And you see there's actually two aspects to that: importance of a raw material in an economic sector and importance of the sector to the EU economy. And the other one is substitution, technical and cost performance. And then we look at the vertical axis on supply risk, and we talk about global supply. Now, this is really starting to focus a lot of people. There's a lot of realization that there is a lot of supply risk out there, and it's increasing. So global supply, market concentration, the HHI stands for a complicated equation called the Hirschman-Herfindahl Index. Governance performance, we're looking at the World Governance Index. Import reliance, trade agreements, end-of-life recycling, substitution. So you put all that together and you analyze it quite carefully, and you see on the little graphic there, there's two lines, and anything in the top right-hand box is critical. And this is how it looks. Sorry for the complexity of the slide, but to keep it simple, you see all the materials that we use in our modern industrial economies plotted down on here, and anything in red is critical. And suddenly you may be thinking to yourself, there seems to be a lot of red. And I'm like, yeah, there is. And some are very red. And this graph here shows a comparison between 2017 and 2020. And if you're sharp-eyed enough, you will notice it's more materials, more critical. Not in every case, but mostly. The direction of travel is up into the right-hand side of the box. So, and this has been the case ever since the assessments were done in 2010. I've been following it and been involved in it very carefully for the EU. And it's just, to put it simply, more and getting worse. So we're not reversing this trend, and it's really becoming quite tense and difficult. Good. How does it look if we plot it all down onto the periodic table of elements? Well, it doesn't look any better, because over the years I've noticed we're getting close to 50% of the elements that we use are critical. So this isn't a weird bunch of just a few materials which are in some special technologies which maybe we could live without. This is mainstream stuff. It's everywhere. And it's especially important, as I'll show in a moment, to the technologies we are now badly needing to build our circular low carbon economies. You'll see there's a range of and again, this is poorly understood, a range of very unusual and odd elements here, which are not well known. and not well understood. The other thing I point out is there's lists at the top there, and you've got things like natural rubber, something that, again, is outside my scope. I tend to focus more on the metals, but you see they're there. The other thing I highlight is conflict minerals, so-called 3TG. Why are they called the 3TG? It's tin, tantalum, tungsten, and gold. And you see them plotted out. 2 of them are critical, 2 of them are not. So I've just sort of put quite a few things down on here to give you some food for thought. I said they're in a range of technologies, and here's some work from the European Commission again. So on the left-hand side, you see very high critical materials down to very low. And then you see a range of technologies. This isn't obviously all the technologies in modern society, but there are a range of technologies, some of which are highly rising in importance for our low carbon transition, like wind turbines, like solar photovoltaics, like motors for electric mobility and so on and so forth, and batteries, of course. And you see there a lot of red lines, a lot of great concern. The other one I point out is the one at the bottom, the ICT. And electronics and digital is seriously affected. Now, the lines might not be very thick, but it doesn't matter, because if you can't get electronics and you can't get digital, I'm curious to see how we're going to develop a circular economy, because all I ever hear from colleagues is digital and electronic. So I think that's something we're going to have to watch out for, and I'll talk more about that in a second. So what do we talk about in buildings? I like this model by Brunt and others, et al. And here we talk about how long stuff lasts. And again, there's a lot of misunderstanding about this, because you go buildings, and I ask students sometimes, what are buildings made of? What are cities built of? And they go bricks and concrete, and bricks and concrete, and isn't it bricks and concrete? And you go, well, that's one part of our built environment. But here you see how quickly stuff goes through buildings. I'm particularly interested in the space plan and services. So that stuff that is going through quite fast. Heating, ventilation, air conditioning, digital services in buildings, smart buildings, all that type of stuff. That interests me quite a lot. As well as the low carbon energy generation on buildings, solar PV on buildings. That interests me a lot. So those sorts of things, I'm suddenly seeing digital, smart, low carbon energy generating buildings and systems. And that is a problem for critical materials. Here's an example. So you take a super building in Amsterdam that's claiming to be the most sustainable and smartest office in the world. Fantastic. So there it is, and it has these little sensors inside. You know, the kind of sensors like where you walk in a room and the lights go on, or you walk out and the lights go off, and so on and so forth, these types of things. Turns out there are 29,000 of these sensors in this one building. And then I pull out here an example from one of our researchers, and she was looking at all the components, individual components inside a sensor. Bear in mind, a sensor, what, 3-5 euros, quite a cheap component inside a building. And you take out a thing called a Schottky diode. If you're an electronics engineer in the room, you'll understand what a Schottky diode is. It's about, that little thing is about 2 millimeters long, 1 millimeter wide, tiny little thing. And then you look at all the elements in bold, which are in a Schottky diode, and they're critical. And then you say, okay, well, can we take the Schottky diode out? Sorry, a diode is a switch. So you just said, can we take a switch out of the electronics and it can still work? Well, no, you can't. So the tiniest of things sometimes have the biggest impact. So, and by the way, all the other components are filled with critical materials, so they're everywhere. What are the challenges? Well, they are many, and there's 6 here that the Commission have identified. Data availability and accuracy on critical materials. So do we understand it well enough? Do we know where it's used? And at first you think, well, how hard can it be? Surely we design the stuff in, we must know where we use it. And the answer is no. It's way worse than additives in food. What exactly do we eat? That's way better understood than this field. Environmental and social dimensions are poorly addressed in relation, and technologies and economics are poorly understood, and they move fast and mining moves slow. So we've got some real problems there. If you'd like to know more about critical materials, because I've gone through it very quickly and it's very complicated, the good news is next week you can join one of the best courses in the world. I would say that, wouldn't I, because I'm involved, for free. And you can study to your heart's content at your own pace with the best people and the best knowledge. And it isn't just me, I play a small role. There are many, many other colleagues from all over Europe and all over the world speaking on this program. So it's available there. Just go there, look at edX online, critical raw materials, managing resources for a sustainable future, starting next week. So your timing is perfect. Okay, let's switch over to remanufacturing. And here we see the classic R ladder, all the different re's that you can do in a circular economy. And I'm focusing here on remanufacture, R6. I'm also interested in R2, which is reduce. And I'll come back to that in a moment because I've got a suggestion around that. But what do we mean by remanufacturing? Oh, you know, people say to me, it's like refurbishing and reusing, isn't it? It's all the same thing. And I go, no, it's not repaired. It's not refurbished, but put through a factory. The product is in a box when it comes out, as good as or better than new, with a warranty, and you can't tell the difference between original manufacture and remanufacture. You take the two products, one's original manufacture, one's remanufacture. You cannot tell the difference when you look at it, operate it, hold it in your hand. It looks exactly the same. Now that you don't get with refurbishing. You can tell the difference, which is the used one, which is the new one. So that's an interesting difference. And here we see it again, put the other way around. So here we're seeing all the different re's and how they compare to the original design specification. And you see remanufacturing is the only circular strategy for product life extension or recycling, the only strategy that's equivalent or better than new. So that makes it interesting. So what have we been doing? Well, we've been running loads of programs. I'm not going to dwell on this too long, but we've had loads of EU funding and we've got something new coming up, which is what I want to come to. And here it is. So we're going to run workshops on lean remanufacturing. And we're going to run them over this year, pilots this year, programs next year. And you notice here, what we want to look at is lean, which is reduce. So we focus on the training content on lean remanufacturing and remanufacturing itself, so going circular. So taking an existing concept like lean and putting it together with a circular concept like remanufacture. And the good news is I'm coming to Milano at the end of the month. And the other thing I'm going to be doing, as well as working with MIP, I'm going to be speaking to a global company with a base in northern Italy to help roll this program out in a series of workshops with them. So that's quite exciting. And what does it mean? Well, we think we are going to have 100 billion euros of opportunity. I work and I sit on the steering committee with the European Remanufacturing Council, and we're trying to develop partnerships with companies to help roll this opportunity out because it's really exciting. And I'm not going to dwell on this too long because it's quickly, but the kind of things we look for is the risks, which I've been talking about, like critical materials, but also other risks, together with business opportunity, then breaking it down into the tech questions and the business questions. How do we make the business model work? So that's the type of thing we do in the workshops. And I want to conclude and finish off with a little looking forward. Now, when I have researchers, students, PhDs, or other colleagues sit in front of me and they go, what can I do in this field? And I go, well, have a look at this diagram. And I know it's a crazy diagram, but what it is, it's Dave Peck's diagram of the gaps. So every line on here is not a good connection, it's a weak connection. And then I say to somebody, pick two things on here and tackle this gap. So there's all sorts of opportunities and interesting areas where there are gaps, in my view. And I share this with everybody and I go, instead of me telling you what I know, I'm telling you what I don't know and where it's understood poorly, and let's work on that. And I think that's quite exciting. And at that, I'm going to conclude because I give some time. I know I've moved through quite quickly. I think I'm in good time. Am I right?
Yes, you are in time a little bit too much, but fine.
Okay.
I'm very happy to have you here again. I think it was really interesting, and probably you just show just the beginning of a really big iceberg. So I really suggest the people to go through all the readings he was suggesting in the class. He was suggesting, because the topic about critical materials is super interesting. Actually, for example, we are talking about doing all. We saw yesterday we need to develop a lot of renewable energies, but we probably don't have the materials to develop all that renewable energy. So, and all the things about the batteries, all the things about all the tech that we have. So probably we are thinking about future, we actually don't have the base to develop. So, and also all the other point regarding remanufacturing, that could be really a potential solution to develop, to recover materials, bringing a product that is actually looks new. I think these are really two very important points coming out from your speech. So
yes,
thanks again.
Sorry, if I may just quickly say, perfect for Italy. Remanufacturing Italia, perfect.
Yeah. Yeah, and I know you're already moving in this direction. So, thanks again. See you soon.